Okay, this is assignment 2.1.9.2, the second part of the ultrasonic distance sensor project or assignment. All right, so again, the way Sonar works, of course, is that we send out a ping, an ultrasonic pulse, sound pulse, and then we listen or we hear something, basically, and based on that, how far away the echo is, basically, we can calculate a distance, basically, just kind of like a bat. So our sonar is going to be a little different. The actual sonar we use for our circuit here, the real circuit, is a little different than the one we use in the virtual circuit. Ours has actually 4 pins instead of 3 pins because we don't share the ping pin. Basically, the ping pin basically is going to be different from the signal pin is going to be different from the pin we receive the ultrasonic sound from. But anyway, basically, again, the idea, of course, is that we're taking the echo from the ping to measure distance. And again, this is very similar to if you ever watched the movie Aliens. They used a distance sensor to measure how far away something is, and that's what we're going to do. We're going to use the piezo buzzer basically to generate a tone that tells us how close or far away something is. So again, the kind of the louder the tone, the closer it is, and that kind of thing. All right. So again, our sensor basically has 4 pins. So we're going to do a little different here than the one we did in the virtual circuit. So just kind of keep that in mind. And again, the pitch is going to go up as the object gets closer. So we're going to use a tone to kind of give us a signal. Alright, so parts for getting this together: we need the Arduino, we need the breadboard, we need your ultrasonic distance sensor, we need a buzzer, 330 ohm resistor, and 7 jumper wires. Okay. Alright, now ours is going to be a little different, like I said. So basically the way ours is going to work is we're going to have our 4 pins connected up, and I'll kind of explain that here in a second. But basically we're going to put in a piezo buzzer into our breadboard. And then on the ground leg of it, so basically in the piezo buzzer, there's a little plus symbol on it someplace to tell you which leg is the positive leg, and then the other one is obviously the ground. For the ground, we're going to put the resistor on there, very similar to what we do with the LED, and we're going to put that into the ground channel, the negative channel, and then the positive channel of our piezo buzzer basically is going to get connected up to digital pin 3. Alright, so again, we start by connecting the 5 volt and the ground to our negative and positive channels on the breadboard. Again, the piezo buzzer, we're going to connect that up. Again, there's a positive indicator to determine which leg is side for current, and a negative, and then the other one basically is the negative one. That's the one we connect to the resistor, and then we connect the other one to our breadboard. And we connect the positive to the digital pin 3. Okay. All right. Now we're going to connect our ultrasonic sensor to the 4 separate channels on the breadboard. Connect the channel of the ground, obviously, to the ground, to the negative channel on the breadboard. The 5 volt goes to the positive channel on the breadboard. All right. And then we have a trig pin, basically, and then we're going to connect that to digital pin 7. And we have an echo pin, basically, and that's going to go to digital pin 6. So those are the 2 different pins that we use on our ultrasonic sensor. That's a little different than the one we used in the virtual circuit. Okay, so now it's time to start coding, and we're going to start with our comments first. Again, we're going to put in some comments about what this program is going to do. Again, we're going to use our ultrasonic distance sensor to measure distance to an object and produce a sound on our piezo buzzer to give us an indication of how close an object is. And we're going to start by initializing some constant variables to set the pins on the Arduino. The distance sensor will use pin 7, and pin 6 will receive the echo from the ultrasonic ping, and our buzzer will use pin 3. Okay, and then inside our void setup function, we're going to put in which pins for input and which ones are going to be for output. Alright, so we use the trig pin inside our void loop function. We're going to set our trig pin on the distance sensor to send out an ultrasonic pulse, which will then read with the echo pin. And the duration in time, but basically will give us the distance, which we can then use to make the buzzer sound. Okay, we're going to create 3 local variables, 2 for duration and distance. these need to be long type, so they can be decimal numbers, and then we want and for how long the object, or for how close the object is to the sensor. All right, so we start by clearing the trig pin so we can be sure it gets a clear signal. We want to delay then for 2 microseconds, and we'll send out an ultrasonic pulse. We'll delay for 10 microseconds, and then we'll clear the trig pin again. All right, then we're going to measure the duration of the returning pulse, and then use that to calculate the distance in centimeters. And then we're going to check the distance and give a sound signal based through the buzzer corresponding to how close the object is to the sensor. The closer, the quicker the clicks. All right, so if the distance between 0 and 15, make time for a tone quick. If it's between 15 and 20, make the time for the tone medium, and then if it's 25 to 30 centimeters, make it for long. Okay. Again, if the difference is greater than 30 centimeters, we'll turn the buzzer off, and won't play anything basically. Otherwise, we'll play at the volume that's set. We're going to wait about 3/4 of a second before we move on to the next, or check it again. Let's go ahead and put those comments into your Arduino editor, and go ahead and run your Arduino editor. Make sure that it actually is working. Okay, once you got your comments tested and your function set up, it's time to come back and start putting in the code for the program. So again, we're going to start by creating 3 constant integer variables for our pins. Our trig pin is going to be 7, our echo pin will be 6, and then our buzzer pin will be 3. We also want to create a integer variable called sound, and we're going to set that to 250. This will be the volume of our buzzer. All right, then we're going to, inside our void setup, we'll set up the different pins for either input or output. So our trig pin is going to be output because we're going to use that to send the pulse. Our echo pin will be input because we're going to receive the ultrasonic signal then. And our buzzer will also be output because we want to send a signal there to turn the buzzer on. Okay, inside our loop, we're going to create some variables, some long type variables. For duration and distance. We're also going to create an integer variable for how close, basically. So that gives us an idea of how close something is to our ultrasonic sensor. All right, now inside our loop, basically we're going to start by sending a digital write to the trig pin of low. That clears out the trig pin, basically turns off any sounds that might be coming out of it. We want to delay for 2 microseconds. Then we're going to send another digital write to the trig pin, this time high, send out an ultrasonic pulse. We're going to delay about 10 microseconds, basically, to kind of give it a second to actually do that. And then we're going to send another digital write to the trig pin for low again to kind of clear it out, clear out that trig pin, make sure it stopped transmitting. Okay. Next, we're going to we're going to capture the information and how long it took to get back to our pin, our echo pin. So our pulse in function will read the echo pin by setting it to high. Okay, and that'll give us our duration. Again, our duration calculation in centimeters. We're going to take the duration divided by 2, and then also divide that by 29.1 to get our distance. There should only be 1 semicolon there, so just to keep that in mind, just 1 semicolon, not 2. All right. Now, if the distance is greater than or equal to 0, but less than 10 centimeters, basically, we're going to set our how close to 250. Basically, that sends a signal to the that'll send our signal to the buzzer, basically of for 250, which is a pretty good sound, basically for being close. If the distance is greater than or equal to 10, but less than 20, then we're going to set we're going to up our how close value to 500. Again, make it a little lower, basically. And again, if our distance is greater than or equal to 20, but less than 30, we're going to set it to 1000. Okay, again, to kind of change the tone on our buzzer. Okay, and again, finally, if it's greater than 30 centimeters, then we're not going to have any tone on our buzzer, so no tone on the buzzer. And then otherwise, if basically, then if it's not greater than 30, obviously, then it's going to be one of the other ones. So we're going to send to our buzzer the tone. We're going to send the buzzer variable, the sound variable, and the how close variable, basically. So, lastly, we're going to wait about a 3/4 of a second before we start with our next thing. Okay, so check your code, see if it runs, see if it does what you're expected to do, and if not, troubleshoot it and get your circuit working. All right, then use a battery pack and walk around the room. See if you can do it with your eyes closed and avoid running into things with your sonar, just like a bat.